Hello and welcome to another college algebra video. This one is the second half for my class at least, or it's the other half, if you will, of section 4.4 exponential and logarithmic equations. This section covers both how to solve two types of exponential equations and two types of logarithmic equations. We are going to focus on the two types of exponential equations that are found in this section 4.4. All right. So the first one is when you can write your exponential equation as a power of the same base. So this is when either you're given the same base or you can match bases exponentially. Okay. And this is using the one-to-one property, just like logarithms have a one-to-one property because they're one-to-one functions, so are exponentials. And so this is not dividing away the base. This is not canceling the base. This is called the one-to-one property. Okay? So, for example, 5 to the 3x minus 6 equals 125. 125 is 5 times 5 times 5. It's 5 cubed. So you can rewrite 125 as 5 cubed and then use the one-to-one property. So here we rewrite 5 cubed for 125. Since 5 to the 3x minus 6 equals 5 to the third, then the one-to-one property allows us to set the powers equal to each other, add 6 to both sides, and then divide both sides by 3. And you get x equals 3. Unlike the logarithmic equations, you do not have to check the domain on these answers because the domain of exponential functions is all real numbers. So if you solve it properly, you're good. All right. Now, for B, 4 and 8 are not directly related exponentially, at least not whole number exponents. However, 8 is 2 cubed and 4 is 2 squared. And so what we're going to do is we're going to replace 8 with 2 cubed. Still has a power of x plus 2. We're going to replace 4 with 2 squared. Still has a power of x minus 3. And then we're going to use the fact that a power raised to another power is multiplied. So we just get 3 times x plus 2 here as the power. Here we get the power of 2 times the group x minus 3. Don't forget the groupings. And so now we have 2 to a power equals 2 to a power. We can use the one-to-one property to say the powers have to be equal as well. So 3 times x plus 2 equals 2 times x minus 3. All right. Distribute 3x plus 6 equals 2x minus 6. Subtract 2x from both sides. Subtract 6 from both sides. And you end up with x equals negative 12, which is the correct answer. All right, so there's a couple of examples. I'd like you to try example 2. 3 to the x minus 3 equals 9 to the x minus 1. Kind of a hybrid between the two you saw. Pause the video, give it a shot, and we'll check it out. Okay, so what are we using here? We're using the fact that 9 is equal to 3 squared. 3 is already over here, so nothing happens to the left-hand side. The right-hand side, we replace the 9 with 3 squared. Leave the x minus 1 up top. All right, just a little note here. You never multiply or increase a value. You can't change the value. You're rewriting the value. 3 squared is equal to 9. I didn't change the value. If I square this 3, I've now changed the value to 9. Does that make sense? So you always want to rewrite. You never want to actually change the value. You just want to rewrite the same value in a different way. All right, so with that done, you get 3 to the x minus 3 equals 3 to the group 2 times x minus 1 using the product rule for exponents. And now you do one-to-one property says the exponents are the same. Okay, so we get x minus 3 equals 2x minus 2. Subtract 2x from both sides, add 3 to both sides, and you're left with negative x equals positive 1, so x equals negative 1. All right? So that's the way you handle it when you can get the bases to match up when they look the same. But that obviously doesn't always happen, right? And so what happens if you have like 4 to the x equals 3? Well, certainly 4 and 3 aren't going to be the same. And so what do we need to do? We need to take the common logarithm on both sides or the natural logarithm on both sides. It really doesn't matter which one you use. They say only common log for base 10, natural log for everybody else. It doesn't matter. You can do either one, right? And so what happens is that allows us to bring the x down. I showed you that in the logarithm equation section video. So let's just walk through it. The directions are a little bit more confusing probably than just walking through the problem. So we got 5 to the x power equals 134. 134 is not an easy power or a direct power of 5. So what do we do here? All right, we take the natural log of both sides. All right, take the natural log of both sides, and then what can you do? You can bring the x down in front. X comes down in front of the natural log of 5, and now natural log of 5 is just a number. Okay, it is just a number, and so you can divide both sides by the natural log of 5. We divide by natural log of 5 on both sides. This divides away, and you're left with x equals natural log of 134 over natural log of 5. These natural logs do not divide away. This does not match the quotient rule. The quotient rule has 1 natural log, not 2. And so you can plug this into your calculator. Make sure that you follow directions on the quiz or in my math lab. It will say express it as an exact answer or express it as a rounded answer. Okay, if you use your calculator, you have to round it off. Make sure you round it to the right decimal places. Okay, so we just took the natural log of both sides, brought the x down, and then divided. So y'all try problem number 2. Okay, so I'm actually going to show you how to solve it 2 different ways. They suggest using log base 10, and the reason we're going to use log base 10 is because log base 10 now is the inverse of 10 to the x, and so there's nothing to do here but just get x. That's the inverse property. And then you have log of 8,000. Okay, and then you can plug that into your calculator. Here's the log button right here, log of 8,000 is approximately 3.903. So to 2 decimal places, this is approximately 3.90. But watch what happens if we use the natural log instead. If we take the natural log of both sides, we get natural log of 10 to the x equals natural log of 8,000. The x can come down in front, so we get x natural log of 10 equals natural log of 8,000, and then we divide both sides by natural log of 10, which is a perfectly good number. Remember, the ln's don't cancel. Natural log of 10 divides away, but you get x equals ln of 8,000 over ln of 10. Now, this is the exact answer. But wait, this is the exact answer. How can they be both? Well, remember we talked about that change of base formula. Well, when you change the bases, you get this kind of relationship. And so if you plug into your calculator, you'll notice natural log of 8,000 divided by natural log of 10 gives you the same thing. They are equivalent. So it doesn't really matter which way you do it. Be careful in my math lab if it asks you for exact answers. It's looking for it in terms of ln probably, but make sure that you express it properly based on the directions. Okay, so these are both 3.90, same number. Okay. A quick example of where you might apply this. Remember our compound interest formulas from way back in section 4.1. Now they're asking for how long will it take? How long? Well, how long is t? T is up here in the exponent. So A is 3,600. P is 1,000. And 8%, 0.08, compounded quarterly, that's divided by 4 to the 4t power. You got to get this t out of there. So we divide everything by 1,000, divide everything by 1,000, These thousands divide away. You get 3.6 equals 1.02 to the 4t. And now what do? You take the natural log of both sides. Natural log of 3.6 equals natural log of 1.02 to the 4t power. That means the 4t comes down in front. That's the power. This is natural log of 1.02. Divide by natural log of 1.02 on both sides. And that divides away. And you also need to divide by 4. And so you get the natural log of 3.6 over 4 natural log of 1.02. That equals t. So we need to approximate this with our calculator. Be careful when you plug that in. We get the natural log of 3.6, close parentheses, divided by parentheses. You're dividing by a product. 4 times natural log of 1.02. So we've got to close this parentheses. You need this product in a group by itself down here. And when you enter, you get 16.17 blah, 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 which is approximately 16.2. And of course, we need units for the word problem. This is 16.2 years. So if you wanted to write it out nice and neat, you would say after approximately 16.2 years, $1,000 will grow to be an accumulated value of $3,600. All right, so that's an example of where you can use this. We just want you to understand the basics of how to solve these two types of exponential equations. And there you go. Thanks.